This video is on integration and we've called it the reverse chain rule. Essentially what you need to think about this is it's a technique to integrate a linear bracket to a power. The word linear is very important to what we're about to look at. We'll think a little bit more about that later. So the way that we're going to start to approach this is we know that integration is the reverse of differentiation. So let's think about what we know about differentiating brackets to a power. So we did a shortcut for the chain rule, which was any function to a power times by the power times by the derivative. I'll take one off the power. A couple of quick examples. So say if I said differentiate with respect to x, 3x minus 1 all to the power of 5. So clearly we've got a bracket to a power, and if you wanted to differentiate this, we times by the power. We look inside, we differentiate, and that gives us 3, so we times by the derivative. And we take 1 off the power, so we'd have 15. 3x minus 1, that's the power of 4. Let's do one more. So say if I was going to differentiate with respect to x, sine squared. That is a bracket to the power, isn't it? Because you can think about that as the derivative with respect to x of sine squared. So we times by the power, times by the derivative, which is cos x, and we take 1 off the power. So that would be the same as 2 cos x sin x, or 2 sin x cos x. Okay, so if we want to integrate, we need to think about how would we reverse the process. You know, what's the opposite of times by the power, times by the derivative, take 1 off the power. You might want to pause for a second and just think about maybe how you could reverse the process. Okay, so the way that you might want to think about it is if we were trying to integrate a linear, now when we say linear we just mean a straight line equation, so ax plus b. Okay, this will only work for linear functions. We'll talk more about that later. So if it was 2x plus 3 or 3x minus 1 and it was raised to a power, we would add 1 to the power because we're integrating, divide by the new power, and also whatever this coefficient is. So say if that was 3x plus 2, you'd be dividing by 3. Really common pattern when you're doing these shortcut for integrations, isn't it? You divide, think about your exponentials in the trigonometry, like if it was e to the 3x, when you integrate you divide by 3. If it was sine 2x, when you integrate you divide by 2. So this coefficient of x is what we're going to be dividing by as well. Okay, so let's try a quick example. Example 1a wants us to integrate x plus 1 to the power of 4. Okay, so clearly we've got a linear bracket to a power, and we can follow the rule, add 1 to the power, divide by the new power, and the coefficient of x, which in this case is just 1. Okay, so you could also, you could just read this, divide by 5, but just be careful, because if that was like 3x, you'd have to divide by 3 as well. I suppose we could tidy it up, we could write it as 1/5. X plus the 5 plus c. Okay, next one, we're going to integrate 1 over the square root of 2x minus 1 dx. Now if I got a question like this in the exam, the first thing that would spring out to me was, it's a fraction. So is this going to become an ln, like the last video? But clearly not. Like if you look at the denominator, if you differentiate this, you're never going to get the derivative on top. Like this is just 1 over, it's 1 divided by a function. It's not going to be a natural log, is it? So instead we can think about it as a bracket to a power. Square root is a power of a half. It's on the bottom, bring it up. This is the same as integrating 2x minus 1 to the power minus a half. And now we've got linear bracket to a power, so we can integrate. Add 1 to your power. Divide by your new power. Now you can write divide by a half if you want, but like dividing by half is the same as multiplying by 2. So I'm just going to write times by 2. And then we've got a coefficient, which is also 2, so we do need to divide by that coefficient. Don't forget plus c. and then we can tidy this up. 2 divided by 2. It would be the same as a half times by 2 on the bottom, which would cancel as well. So you've got 2x minus 1 so plus c. Part C is, again, a fraction. So it might be worth just checking, oh, is this a natural log derivative on top? No, like if you, that's a quartic, and if you differentiate a quartic, you get a cubic. You've not got a cubic on top. So we can just write it as a bracket to a power, which would be 1 minus 3x. It's the power minus 4. Add 1 to the power, just be careful, add 1, so you get minus 3. Divide by the new power, which would be minus 3. And the coefficient, which is, don't forget, it's the thing in front of x. Don't forget that there's a lot of people forget the negative for some reason. That is, the coefficient of x is minus 3, isn't it? So we're dividing by minus 3 as well. And then tidying that up. Minus 3 times minus 3, we could write it as plus 1/9. 1 minus 3x to the minus 3. Plus c. Last thing, I just wanted to quickly think about what I mentioned at the beginning. Like, this is a technique to integrate a linear bracket to a power. There's other integration techniques that we're going to look at, like parts and substitution. And then further maths, there's loads of other integration techniques as well. But just be really careful with this short. If you are going to use this shortcut, it only works for linear. So say, for example, if I said integrate 1 over the square root of 2x plus 1 dx, you would think, right, well, I can write that as a bracket to a power. That would be 2x plus 1 to the power minus a half. And that's fine. That is linear. Ax plus b, we can use the shortcut. Okay. What about if I said integrate x cubed minus 1 to the power 5? Okay, now what you might think is, oh, I've got a bracket to a power, so I'll add 1 to my power, I'll divide by my new power, and I'll divide by maybe 3x squared because it's the derivative, but like, please don't do that. Like, that is not a linear function. So you do not use the shortcut on this one. You could use the shortcut on that one. Do not even try to integrate this using the shortcut. We actually couldn't really integrate this one at the moment, so we'd have to do some sort of substitution, and to be honest, that wouldn't even work anyway. But like, just, we can't integrate a function that looks like this. Another common one, right, which we'll see a lot later of, if you wanted to integrate sine squared, people think that we can integrate it as sine squared, because if we were going to differentiate it, we could differentiate it using a function squared, but integration's a lot more strict. Like, that there is not linear. Ax plus b, it is a function that's being squared, but it is not a linear function, so we cannot use the shortcut on these questions, so just be very careful. Okay, so last thing to try, guys, is there's another exercise. Oh no, there isn't actually. Yeah, no, there's like, there's it. Yeah, that's basically it for the chain rule shortcut. So once you've worked through the other exercises in the booklet, it's time to try the assignment. Okay, and there's only 3 questions on the assignment, so and they do range in difficulty. Like the last one is quite tough, but we're doing that intentionally to give you like a variety of questions and a bit of a challenge as well. So please just contact me or Johnny or Steve if you need any help on the assignment questions. It'll be due in for next Wednesday. So the one for this week is the second differentiation one, but this integration assignment will be in for next Wednesday. Thanks, guys.